T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch over.
And there you have it, 22 hours after the last one, we're off the pad again for Ice Ice Baby. Now that it's cleared the pad, Electron will soon approach max Q, or maximum aerodynamic pressure, and that's the moment in flight when Electron experiences peak structural load. We'll hear that call out from GNC team in mission control shortly, so let's keep an ear out.
Vehicle is supersonic, approaching max Q.
HV discharge nominal.
Cleared max Q.
That's what we like to hear. Electron has successfully sailed through max Q. We are now at 17 kilometers in altitude and traveling at over 2,500 kilometers an hour. Up next, in quick succession, we will see main engine cutoff called MECO, stage separation, and then stage 2 engine ignition. All three events take place within seconds, so it's a busy and complex point in flight.
Guidance is nominal.
Having completed their role in the mission, all 9 of Electron's Rutherford engines will shut down to prepare for stage separation. Once free from stage 1, stage 2's single Rutherford engine will ignite to power Electron the rest of the way to orbit. Let's listen in for those calls.
In 30 seconds.
"15 seconds to staging."
Enter burnout detect mode. MECO confirmed. Stage separation successful.
Nice.
Stage 2 ignition confirmed.
That's 3 for 3 successful MECO, stage separation and second stage ignition confirmed. You can see at the top right of your screen there that Electron is moving at 8,170 kilometers an hour, now passing just under 100 kilometers in altitude.
Now that we are well and truly in space, we no longer need the fairings which protected the CNES satellites from these intense conditions as it traveled through Earth's lower atmosphere. The operators in mission control will make the call for fairing jettison soon. And that there was the call out for fairing jettison from mission control. With just 6 minutes remaining in the second stage burn, we are at an altitude of 123 kilometers and about halfway through today's flight.
We're getting some splendid views there of the second stage from the second stage camera with its Rutherford engine propelling us past 9,800 kilometers an hour. Now this Rutherford engine is the same as the 9 on stage 1, except for that nozzle that you can see glowing bright. That nozzle extension allows for the combustion gas to expand to a higher velocity before leaving the engine, and velocity equals thrust. All of that to say that it gives us a much more efficient ride to orbit.
Stage 2 propulsion nominal.
Electron's second stage engine continues to burn nominally as we make our way to space on our 56th launch. The Rutherford engine is unique in that its fuel pumps are powered by batteries rather than a traditional gas turbine. This allows us to extract high performance from the engine and control throttling. Once we deplete the power in the first set of batteries, there's no need to carry this dead weight for the rest of the mission. So we jettison them and swap to a fresh set for the rest of the journey. It is a maneuver we have fittingly called battery hot swap, and it's up next. So keep an eye on your screen to see the shiny silver batteries eject and fall away. But watch closely, because if you blink, you'll miss it. Let's listen in for the call.
AGB discharge nominal, approaching hot swap in roughly 30 seconds.
Guidance is nominal.
Battery jettison confirmed.
Hot swap successful.
Battery hot swap successful. That fresh battery pack is now helping to power Rutherford the rest of the way to orbit. There is just one milestone remaining before the kick stage separates, ready for payload deployment, and that is SECO, or second engine cutoff. The final engine cutoff is coming up at just over 9 minutes into the mission.
FTS has saved.
All right, T plus 7 minutes into the flight, and Electron's second stage is performing nominally. Just a few minutes to go until SECO and kick stage separation, and we'll go into a little bit more detail on that a little closer to the milestone. Then it'll be about 45 minutes until we get to the business end of launch, and that's payload deployment. If you've seen one of our previous launches for CNEIS, you'll have no doubt seen the nifty manoeuvres we'll do with the kick stage to deploy their satellites into the optimal location. Using our cold gas RCS, or reaction control system, we can rotate, flip and reorient the kick stage along the same path for precise payload insertion.
Stage 2 propulsion holding nominal.
Just under a minute left in the second stage burn. We're getting close to orbit there, exceeding speeds of 23,000 kilometres an hour and at an altitude of 205 kilometres. When you hear the call out, entered burnout detect mode from our mission control operators, you know SECO is coming up close. It means the engine is throttling down in preparation for shutdown, officially completing Electron's journey to orbit in preparation for kick stage separation. You'll hear that call soon, so let's check back in with the team in mission control.
SECO confirmed. Stage 3 separation confirmed.
And there we have it. Electron is in a transfer orbit as planned, and the second stage engine has shut down successfully. The kick stage carrying all 5 CNEIS payloads has also separated and is entering the coast phase for around 45 minutes. Once at apogee, the kick stage's 3D printed Curie engine will ignite and complete the final leg of the mission. That is, kick stage circularization and payload deployment to 643 kilometers altitude.
The satellites on today's mission will be deployed in a precise order. First, a single satellite will be deployed off the top of the kick stage, followed by the remaining 4 satellites deployed in pairs from opposite sides of the kick stage. That final phase of the mission is scheduled to take place at around 45 minutes or so from now, so we're going to take a short break while the kick stage circles the globe. We'll leave you with a graphic of where the kick stage is above the Earth and the chill tunes of our good friend, the everyday astronaut. We'll be back with you soon for payload deployment.
Of Ice Baby, our 56th Electron launch. So far, we have had a textbook flight with Electron successfully lifting off from Launch Complex 1 and carrying 5 satellites to orbit for French Internet of Things constellation operator CNES. Those satellites are now just minutes away from being deployed to their final orbits by Electron's kick stage.
The Curie engine's work isn't done after orbit circularization and payload deployment, though. It has one final mission, an orbit lowering maneuver. Now, we do this to bring the kick stage closer to Earth, where it experiences more atmospheric drag, helping to speed up its demise, and eventual deorbit, helping to keep space sustainable.